Hi everyone, in this video we'll be learning about write-ahead logging. So mainly we'll try to answer two main questions. First is what's the purpose of using write-ahead logging? Like why does the database use write-ahead logs? Second is we'll see how the log file looks like on a high level. Okay, so let's get started. So first of all, let's try to understand what happens if we don't use write-ahead logs. Okay. So, by the way, I hope you remember that in one of the previous videos, I have explained you what is pages and what's the use case of this. So basically your table, right, your database table is stored into this pages. For example, let's say we are dealing with some users table. So some rows of users table would be present in this page number 1. Some would be present in page number 2 and so on and so forth. Okay, so this is how your database table is stored onto the disk, right? So this pages would be present onto the disk. Now the thing is, let's say I want to, you can say, fire this particular statement wherein I am updating the name of the user whose ID is equals to 6. So whatever that user name is, I'm just updating that to Shubh. Okay. So in order to update that, first of all, we want to find the page which has this particular ID. First of all, we want to find the page which has a row with ID equals to 6. Okay. So one by one, we'll bring all the pages onto the RAM. All right. For example, let's say first I bring this page onto the RAM. We'll not bring this page, we'll make a copy and bring that copy to the RAM. And over here, we'll find whether there is any row whose ID equals to 6. So over here, we don't have that row, right? So we'll discard that page. Then we'll bring another page like this. And indeed, over here, we can see that we have a row whose ID equals to 6. So before updating that, we would put a lock over here, right? We'll put a lock over here on this particular row, so that no other transactions can update this row while I am updating this row. Okay. So now once I put this lock over here, I'll update the name. Done. And I'll send a success response to the client that, hey, your statement was successfully executed. Okay. So the thing is, there's a problem in this particular flow. The problem is currently your update is present into this RAM. It is still not flushed onto the disk. And if you know about RAM, then you might be knowing that the RAM is a volatile storage. That is, if your machine crashes or if you shut down your machine, then all the data which was present in RAM would be, you can say, wiped off, right? So let's assume that your database server got crashed at this point of time. Then it means that the client thinks that his update was successful, but this data which was updated in RAM got lost, right? So this violates the D in the ACID property. D means durability. Your data should be durable. Whatever you create, insert, delete, etc. should be durable, right? But over here, it's not durable. Why? Because we are not using write-ahead logs. Write-ahead logs is something which you can say prevents such problems. So now let's try to understand this flow again, but this time we'll be using write-ahead logs. So over here, we'll again try to execute the same SQL statement. Again, we'll first try to find the page which contains the row with ID equals to 6. So one by one, all the pages would be, you can say, brought onto the RAM. So first, let's say we bring the copy of this page onto the RAM. We'll see whether a row with ID 6 is present or not. Over here, it's not present. Okay. So again, we'll discard this page, then bring another page. And over here, we can see that there is a row with ID 6. So in that case, First of all, we'll lock this row. Okay, let's lock it, and uh, we'll update this row, right? And as we are performing this query, this statement, we would also copy this statement in something called as write log. So this is the write log file. By the way, this is not a single file, it is a sequence of files, because see, each file has some limit. I think the limit of this write log file is 16 MB. So each file would be of around 16 MB. Once one file reaches that 16 MB mark, we would be using the second file, then third file, and so on and so forth. Okay, so in this particular file, we'll be storing this particular statement, right? So once we perform the update, we'll store this statement over here. Similarly, if let's say this is a transaction of multiple statements, then one by one all the queries would be executed, and we'll be storing that onto the log file, this file, right? And finally, there would be a commit message over here. So either commit message is written by you, or in many databases there is one option called as auto commit, which is generally turned on. So even if you don't write the auto commit, then also that commit statement will be executed after each SQL statement. Okay, so under the hood, database executes this commit statement after each statement if that option is on. So over here, let's assume that option is on, or assume that you yourself write this commit statement. So in that case, once this commit statement is fired, that will go into this particular log file. Okay, right? And obviously we'll release all the logs as well. So first of all, once you fire this commit statement, all the logs would be released on this row, and you would also write that commit record in this file. And point to remember over here is, we have to flush this file onto the disk, or you can say save this file onto the disk. What do we mean by this? See, whenever let's say you are writing something on a notepad file, or notepad, or any other file, then let's say you have written something and you try to close the file, then obviously you'll get a message that, hey, you have not yet saved the file, right? So you are getting that message because whatever update you have performed on that file is in RAM. In order to save that, you need to press Ctrl S, right? Similarly here, whatever queries or statement you have written into the file is currently in RAM. Once you find this commit statement, you have to flush that onto the disk. So that should happen, and after that happens, you would send the, you can say, success response that, hey, your update was successful. Okay, so your client will get this acknowledgement. Now the good thing over here is, if at this point of time, if your database server got crashed, then the data which is present in RAM will obviously be lost, but you have already noted down the SQL statement which was executed, right? So when the database server starts again after, let's say, 5 minutes, okay, so at that point the databases can start executing all the queries which are listed over here, or you can say statements which are listed over here. And by the way, it will not execute all the statements, because there can be millions of statements in this log file, right? It will not execute all of them. Instead, there is something like a checkpoint. Assume that this is a checkpoint. So all the statements above this checkpoint were already executed, and the data corresponding to that statement was flushed onto the disk. All right, the data corresponding to the statements was flushed onto the disk, but the below statements were executed, but the data corresponding to that statement was still in the memory, right? So that's why when the database starts again after crash, then it will just execute all the statements below this checkpoint. Okay, got it? So this is how write-ahead logs helps the databases achieve durability. Okay, and one more thing that I want to highlight is in many of the databases like Postgres or MySQL, they generally do not write the SQL statements over here. Instead, they mention some low level stuff like this. So they will have a raw binary data. The data will be stored in binary format. They will also note down the page number where the data should be stored and the row number in that page where the data should be stored. Okay, so instead of writing this SQL statements, they generally write something like this. The benefit over here is this is very fast compared to this. Why? Because over here the SQL statement needs to be executed first so that we can get the data, but over here we already have the data. Okay, we just need to go and put this data on page 132 row 48. That's it. That's why this is way faster and generally preferred by most of the databases like Postgres, MySQL, etc. All right, so I hope with this video you understood what's the need of using write-ahead logs. So databases basically use write-ahead logs so that they can guarantee the D in the ACID property. D basically stands for durability. All right. So if you found this video helpful, then please like the video and share this video with your friends. Thanks for watching.